Hello, I'm Caroline Walker, and I'm speaking today about operational analytics and the Forecourt. Little bit of background information about me before we jump in. I'm with the company Warren Rogers. We provide compliance monitoring and also fuel systems diagnostics to retail petroleum operators, including several Sigma members. And one of the things I really find most exciting about my job is what I get to talk about today. And that is creating and mining these very rich data sets of information harvested from the forecourt. So let's jump in. Little overview of where we're headed in this talk. Any data analytics endeavor is only going to be as good as the quality of the data collection and data curation effort that underlies it. So we'll spend some time looking at important things you want to take into consideration as you lay the framework for everything that will rest on it. But I'm actually going to come back to that at the end of the talk because I want to jump in by addressing the big question, why? Why collect this data in the first place? What can we do with it? And when we think about what can be done with this rich data stream coming off the forecourt, there's so many things. I could easily fill a 5-hour talk, but probably nobody wants to hear me talk for 5 hours. So we're going to focus in on one area of application, and that is how this data can be used to help you optimize your field maintenance activities. So specifically, we're going to look at how this data can be used to reduce service costs, enhance your customer's experience, maximize fuel sales, and minimize loss. And a theme that we'll see throughout as we look at examples of all those things is how data like this can be used to move what might be a more traditional maintenance program to a program that incorporates more predictive and directed maintenance. So let's begin and frame our conversation by picturing in our mind what a maintenance program might look like in the absence of forecourt data. There's probably a lot of activities that fall into this category here of routine maintenance, or we can also think of that as calendar-based maintenance. Things you're doing on a schedule because the calendar tells you to. It's September and we do this every 12 months. Things that fall into this category would be meter calibrations, often filter changes, things like that. And then we've got another category of items. These we can think of as targeted items. And these are things that are brought to your attention because someone identified a problem that they want to have looked into. So it could be coming from your store general manager, something they noticed on a walkthrough, or something a customer complained about. Could be items identified by regulators, your environmental group, loss control, or logistics providers. And the question I want to ask here is there room for improvement in this process? What if you could know about some of these issues as they are developing? Not wait for them to become full-blown problems that you're then relying on someone else to report to you. And goodness knows, I don't think any of us want to be relying on our customers to tell us we're having a maintenance issue, right? First of all, that's not efficient maintenance. And second, that's just not a good use of our customers, right? What else? What if you could have more complete information about these issues before you dispatch? What if there are diagnostics you could run that could rule out many of the things a technician might be inclined to investigate when they go to the site and point them right at the specific thing that needs attention? And how about those intermittent issues? How many times has it happened where you've sent a technician to a site to investigate something and they go out and they check it out and they come back and the report is there was no problem, everything was working fine? Well, those were not maintenance dollars well spent, right? You're almost certainly guaranteed in that situation to be sending another technician out on another day to investigate again when that issue pops up. So what if we could put more information in the technician's hands before we go so they could understand what's triggering that intermittent issue and find it the first time they go? Finally, What if you had tools to help you assess the potential impact of various competing issues? Because none of us have unlimited maintenance dollars to spend. None of us want to be spending unlimited maintenance dollars, right? So, how about some tools to help us understand the return on an investment we're getting for the maintenance decisions we make? So, we'll look at examples of that too. To begin with, we're going to jump into that first bullet point there, know about issues as they are developing. Here's an example of a diagnostic you can develop to do just that. So what we're looking at right now is a dashboard that will tell the flow rates of all dispensers. Here we're looking at unlead dispensers in a population at a point in time. But I want to be very clear here when I talk about flow rate, because we're not just showing the flow rate of the most recent transaction on that dispenser. It is never a good idea to base maintenance action off a single data point. So there's definitely some analytical work that will go into thinking about how do you want to best evaluate and summarize the flow capability of a dispenser. But once you've done that work, you have the ability to put it at your maintenance department's fingertips, at your own fingertips, right? And you can look at a dashboard like this and see all those green bars and know very quickly all those dispensers are dispensers where the flow rate is frustrating no one. Now that's very different than a situation where you have to assume all those dispensers are frustrating no one because no one's complained, right? Now you know. And then unfortunately, you've got some small red bars over there showing you places where the dispensers probably are frustrating someone. The flow rates have gotten low. So you want to be able to drill down into that data, pull up information on exactly which dispensers are having the issue so you can address them. But what would be better than knowing about this issue in real time as it happens? What if you could have known this issue was coming and taken steps weeks ago to prevent it from reaching this point where it now may be frustrating a customer, resulting in lost fuel sales or lost store sales? Well, here's an example of exactly that. If you take a step back and think about this data that you're collecting, and you're collecting it in real time, but you're also saving off historical artifacts, that's going to give you the ability to do these powerful time trend analysis to detect patterns like what we're looking at here. So here we've plotted the flow rate over the past 10 weeks for a dispenser. And we can see for the past 5 weeks, the first 5 weeks in this plot, this dispenser was doing great. Couldn't ask for better, right? It's an auto dispenser. The flow rate is 9.8, 9.7, fantastic. And then in early September, that flow rate starts to fall, and it keeps falling week after week. And now it's at 7 gallons per minute, which isn't ideal, but probably not frustrating your customers. If you have this information in hand, you have the ability to schedule maintenance work here before this dispenser hits the point where it's already frustrating a customer, where it became a full-blown issue. Meter calibrations. Here's another example where remote diagnostics will enable you to know, without having to go to the site and run a test, how much drift has accumulated on every meter in your population. And when you think about the advantages of knowing that and basing calibration actions off of that, let's think for a minute, for example, about an auto dispenser that has reached 5 cubic inches of drift. That's the equivalent of 43.3 basis points off every gallon of fuel sold. So once you know this, you have the power to decide, I think it would be cost effective to calibrate that dispenser now, rather than waiting for the calendar to tell you it's time to stop losing fuel on every sale. Dispensers down. All right, you don't need me to tell you why having a dispenser down is a problem, right? But what I do want to talk about is how very exciting the data around dispensers and dispensers down can be when you've got this real-time data stream coming in and you're mining it. Because now you have the ability to get to know your dispensers very, very well. For each dispensing position and each fuel sold, you have the ability to know how much that position typically sells in a day, how long it typically goes between sales, and how long it's currently been since its last sale. So you can develop alerts and dashboards like this where you can query how many dispensers selling this product haven't had a sale in 24 hours. And that's what we're looking at here. And we see a number in this example dashboard, right? We've got 5 of them. What's really interesting here is also to pull in not just who's down, who hasn't had a sale, but we've got this other column showing us typical daily sales. And you can see there the dispenser at site C typically sells 300 gallons a day about, while the dispenser at site D typically sells almost 6,000 gallons a day. So even though these dispensers are both down, they're certainly not equal dispensers perhaps in terms of business value. So when you've got all that information collected in one place, you can really make better decisions. All right, so we looked at some examples of knowing about issues as they're developing. Now I want to move to how this data can be used to give more complete information about issues before you dispatch to investigate them. Kind of to frame that conversation, here's some numbers to take a look at. These were presented at the NAC show in 2014, estimating the cost of a service visit. And this study was done in 2014, so certainly those costs are probably only higher today. The question I want to ask is, how many of your maintenance tickets are taking multiple visits to resolve, and why? We want to develop tools with this data stream to help your technicians get to the root of issues faster. So we mentioned these analytical tools that are going to give your technicians clues as to the triggers of intermittent issues, visuals to look at so they can understand the context of the issue at the site, and diagnostics that can be run before you even dispatch that will change what you're asking your technician to do. It's going to allow you to be much more specific. So let's take a look at our first example. Here's an STP performance report that can be run remotely. And I'd like to talk through the scenario where this becomes particularly useful. So if you're like many companies, you probably have a number of maintenance tickets generated that say something like, store X is reporting bad flow rates. Well, if you dispatch a technician based on just that information, there's a lot of things they may need to check and rule out before they truly get to the bottom of the problem, right? Do they need to think about filters? Think about the STP? Think about, was this a case where maybe a line leak detector tripped and for a period of time the system was in slow flow? Do they need to think about a tank cleaning to finally resolve the issue, right? If you run a diagnostic like this one before you dispatch, and you got results like we're seeing on the screen here, then you could tell your technician very clearly, this site is having an STP issue. When 7 dispensers are in use, we're seeing only 57% of the flow that we expect to see. The flow rate is terrible when 7 dispensers are in use. So now your technician knows to begin with the STP, and you've also circumvented that potential problem where a technician could have gone to the site, tested the flow rate when just 1 or 2 dispensers were in use and said, hey, the flow is great, no problem here. Now you know, right? You've clued them into that trigger and the exact item that needs attention. Also helpful in situations like these are the ability to analyze flow patterns remotely and put a flow issue in context. So you can look visually and see, did this problem develop very rapidly, perhaps in response to an event like a delivery? Did it affect all dispensers at once or just a few? Or is this a problem that's been building very slowly over time? If you see a pattern like the one shown here, which is showing very erratic flow patterns, not just across this dispenser, but all dispensers pulling from the same tank, well, that clued us into a rag that had been caught in the STP. So these patterns are just very exciting to get to know and analyze. Siphoning issues. This is another example of how a diagnostic run remotely can put great visuals in the hands of your technician. So if you're sending a technician out to a site to investigate a siphoning issue, if they have the ability to see a plot like this, they can quickly assess, wow, that delivery that came in at the end of the day on September 30th, It took 2.5 days for the siphoning on that delivery to complete. Even if your technician happens to show up late in the day on October 3rd, when the two tanks are now equal in level and selling well, they have great information about the problem as it played out before they got there. All right, the last piece of analytics I want to get into before we start talking about how to collect and curate this data are tools that can allow you to assess that impact of all your various competing maintenance issues. And I want to emphasize that once you have this rich data stream available to you to mine, you'll have the ability to look into with great detail the questions that are of most interest to you, that will add the most value to your business. And so just to kind of motivate that and get the wheels turning, I wanted to show you a few studies we've done with this data. Hopefully it will inspire you to think about what questions would you like to answer if you had this data. So here's one study looking at how flow rates impact sales. And we were looking specifically at the average size of a transaction as it related to the flow rate of a dispenser. What we found was that when a dispenser was flowing at less than 4 gallons per minute, the average transaction size was 8 gallons. Now compare that with the green bar over here. When the flow rate was 8 to 10 gallons per minute, the average transaction size increased by 1.3 gallons to 9.3 gallons on average. So that can be powerful information when you're trying to evaluate and make cost-benefit decisions about when should I take action on a flow rate. Now you know how many gallons are on the table, right? What the potential sales benefit would be in a given market for making that choice. Here's a second study where we looked at the same question from a slightly different angle. Instead of looking at average transaction size, we were curious about how the number of transactions a dispenser did in a day changed when the flow rate increased. So we looked at dispensers that had had a flow problem, which was subsequently resolved, and we broke the dispensers up into two groups. So the red bar there, orangish red, is showing us what we consider high usage meters. These are the meters located in the positions that your customers prefer. We can identify those in the data. Physically, they're probably the position closest to your store, the easiest one to pull into. And then in the blue are your other meters, those positions that customers go to, but probably only when the high use position is occupied. So what we found, as you can see in this graphic, was that for high use positions, increasing the flow rate by 2 to 4 gallons generated an on average almost 3 additional sales per day at that dispensing position. And when you think about the fact that on average 1 out of 2 fuel customers also go in the store to make a purchase, there's a second degree benefit there of boosting the number of transactions a dispenser does. Even more exciting than this result, we looked at that same study at those dispensers that had had a more severe flow rate problem. So the flow rate after maintenance increased by more than 4 gallons per minute. And you can see the big red bar there showing you that jump in transactions. Those high use dispensers that had such a big jump in flow rate began to generate on average 6 additional transactions per day. All right, so there are some assessments related to flow rates, but there's no limits to what you can analyze once you have this data, right? You can know the sales impact of any of your maintenance activities. And here's an example report that we use to see how sales have changed in response to a maintenance event. So at this specific site, you can see that the before and after sales numbers led to over 1,000 gallon increase in sales, which represents about a 6% increase in sales for the site. And it's fun, once you have this data, you can also drill down further and see how that sales pattern played out across the meters. So right in the center of that plot, dispenser 18, that was the one that was having the issue, right? The blue bar shows sales before maintenance, much lower than sales after. But what's also fun to look at is how the other dispensers at the site compensated for dispenser 18 when it was struggling, right? You can see 19 picked up a little bit, 22 and 23 picked up some too, but an important takeaway is that the amount those others compensated with didn't make up for all that was lost from 18. All right, so we talked a lot about analytics. Now let's talk about the data that underlies it. What do you need to do to build a data stream of actionable forecourt information? Well, there's two places that are key that you want to pull data from. You want to exploit your ATG to get accurate product levels and water levels, and your dispenser meters to get accurate sales. And together, that's going to give you a data set of fuel movements and transfers. And you're going to aim for high frequency data collection, because that's going to give you a finer resolution into the things you'll be able to see in that data and the conclusions you can draw. And you want to create a data stream that you'll be able to use for real-time analysis. Once you've got that data coming in, what do you need to do with it before you can start reaching conclusions? Here's our data curation phase, right? If you're like most operators and you have multiple types of equipment at site, maybe multiple makes and models of ATGs or dispensers across your site population, then you're going to want to think about data standardization. You want to make all that data uniform so that you can do aggregate analyses across all of it, not just each site by itself. And the other benefit you will gain by doing that is that then those analytical tools you develop to sit on top of your data can be applied to all the sites. Second point here, I couldn't talk enough about this, right? But once you get your data, you're going to want to spend some time getting to know it. And your goal is going to be to discover the anomalies in that data, because there will be many. And you want to learn those anomalies and develop tools for cleaning them or flagging them, because you don't want to let spurious data trickle into your analyses and corrupt your conclusions. You have to be very vigilant about data flagging and data cleaning. So I put 3 bullet points up here just to get the wheels turning, things you want to be on the lookout for, but there will be many more, right? So site maintenance events, if you have a probe pull, that's going to give you erratic tank readings. You need to clean those out or flag them. Any run out or overfill events where you may not be able to get as accurate a reading from the probe, you want to watch out for them. And disrupted communications, you need to flag those, because you do not want to confuse a time where your site was not selling fuel with a time where your site was selling fuel, but communications were out and you couldn't see it. Once you've done those things, you'll be in a great position to analyze the data and to start saving off archives to maintain the value of your data over an extended period of time. That will enable those longitudinal analyses that are very beneficial. One more thing you might want to think about doing with this data, right? We talked about the tank data, the dispenser data. Each of those things by themselves is quite informative, and there are insights to be gained. But you really gain deep insights when you marry those two data sets together and now think about modeling your fuel system as a whole, right? Rather than analyzing tanks separately and meters separately, you want to analyze your fuel system. In order to do that, you're going to need to develop and maintain some metadata to incorporate in your modeling. And I've put together here some bullet points to keep in mind as you do that. You're going to need to develop proper meter to tank mappings, which dispensers are pulling from which tanks. If any of those dispensers are blending dispensers, you want to have in your metadata the proper blend ratios for the dispensers. If your tanks are manifolded, you want to incorporate that in your metadata so you can account for product flowing back and forth between the tanks. You certainly want to be doing continual temperature compensation to get accurate net product readings, product volumes. It's not a big deal. I mean, there's already temperature readings you can harvest from your ATG, but you need to utilize them. And finally, once you have done all that, you're probably in the most exciting position of all. You'll be ready to start building these custom charts for your tanks and manifolded tank systems that are going to give you the accurate and correct inches to volume conversion for your tanks as they are in the ground. Not some theoretical tank, built to factory specs, but your tank as it sits in the ground, as it's positioned. And what that will do for you is it will remove volumes of noise from your data so that you'll be able to get those deeper insights from your data stream. All right, so In conclusion, just summarizing where we've been, we just talked about data collection and data curation, so I won't rehash it. But just to recall kind of the main benefits you could look for once you build this data stream. It's going to give you the ability to target your maintenance actions, right? Problem dispensers, fueling positions, out of tolerance meters. You no longer need to rely on a calendar. You can know in real time when you're having a problem and choose how you want to react. Second, you'll have tools to help you resolve maintenance issues with fewer service visits. And third, overall, it's going to help you get the most from your maintenance dollars because you can set these thresholds for action that are going to help you maximize sales, minimize loss, and overall defend your value proposition. All right, well, thank you so much for listening. I hope this has been informative. If it brought up any questions for you, please feel free to reach out. Here's my contact information. Thank you.